POL360 is the first individual VR motion controller that leverages the principle of light polarization. So it supports 60 watts. The contribution is like this. So this is mobile compatibility. So it does not require additional computer resources like PC or console, or pre-installation is required in the environment, and also on-device computing. So the computation for positioning is completed on the microprocessor in the devices. So it does not rely on any computer resource of VR headset. And last one is competitive accuracy and update rate. So as you know, in the VR, it requires lots of very high accuracy of the positioning, and also it requires very high update rate because of latency. But it accomplished 0.691 centimeter for mean error of position accuracy, and also 0.73 centimeters for standard deviation of the position accuracy. The basic principle is polarized light. So it's come from I've got inspiration from the ant that lives in the desert. When the ant lives in the desert, go to find food, it goes like, there's more than 200 meters. When they go back to home, they don't have Google Maps, so they cannot recognize where that is, where they are. So they use light polarization of the sunlight. So they have the polarizer under their eyes, and when the light is reflect the air, the light also be the polarized. So they use the polarization. I read that kind of article, so I did the modeling of the right side. So my techniques is PLS, polarized light sensing. So it comprises of two parts. First one is LED and a polarizer, and second one is sensor part. So sensor is comprised the photodiodes and thin polarizer. So the basic physics principles comes from Zond's law, as you know. So if I input the photodiodes behind the second polarizer, the intensity which is detected depends on the differential angles between two polarizers. So this is our sensor part diagram. So each phase has four types of photodiodes. Actually, four photodiodes, and each photodiode has different angle of the thin polarizers. So this is our coordinates. So you can see the formulation in the paper. So finally, this is an implementation. So this is our one type of the controller. The upper side, is like all types of sensor parts. So there's dodecahedron, so it has 11 faces, and each face has 4 photodiodes, to totally 44 photodiodes in that area, and dodecahedron type. And 4 layers of PCB board. You can find the function button, recenter button, trigger button, grip button, and also battery type. The bottom side is a more detailed figures of the sensor part. To evaluate our performance for 60-watt positioning, we are making special apparatus for evaluation. So it is called ARMI, so automated rotation metric instrument. So it comprises of 2 parts. For A is the lighting source part, and B is the sensor part. So we can manipulate alpha and beta, gamma, and all angles of sensor parts. So we can make some special situation using this apparatus. So alpha, beta, gamma, and R means the distance between light source and the sensor part. So we do an evaluation. So this is the final result. So basically the mean position error is 0.691 centimeters, and precision means standard deviation position accuracy is about 0.73. And also we show that this POL360 has competitive controller types because it has pretty small power consumption level, and also the latency is 16.67. It means that it can support upper 60 hertz for update rate. Yes, this is a demo. So we are making 4 types of demo. First, in shooting style, it shows that the pretty accurate heading for using our controller, and also free slicing with axe. It shows that friendly movement. Whack-a-mole, it shows that the z-axis movement, and the last one is squash. It shows that also friendly movement. So I'd like to show you demonstration first. Yeah, this is general mode. So you can see the VR headset, and the small lighting motions is attached to the VR headset downside. Yeah, this is a shooting style demo. First slicing. The man is me, but I'm not a good gamer, so I cannot do well, but yeah, it works well. And also whack-a-mole demo. So he shows that z-axis, so back and forth movement. Yeah, this shows the squash. Yeah, so we are making this kind of demo using Unity, so you can support simple SDK. Yeah, I'm not a good gamer. Yeah. Okay. Actually, this work has a limitation, and we need do something more in the future work. So first is multiple light source. In this work, we only implemented a single lighting source, but in the future we have a plan to expand multiple lighting source to make the more bigger environment for a user. And second is the modeling of shape of the array. So in this algorithm, in this work, we assume that the intensity, it depends on the inverse R-square rho. So we do not assume that the shape of the array, but in the future work, we will do more detail of the lighting the shaped array. So the conclusion of this work is POL360 as the first motion controller that leverages the light polarization for mobile VR devices. And also it enables the user to see their hand motion in virtual world via its accurate 6QF position tracking. And also compared to the other techniques for VR positioning, it bears several important advantages: accuracy and affordability, and comparative accuracy and update rate. So, and also I'd like to introduce extended work. It's not about VR, but extended work. So today we extend this work to precise indoor positioning for self-driving vehicles, for example, cars or robots. So the problem we're seeking to solve is this kind of problems. When the vehicles getting into the indoor parking lots, it cannot receive the GPS signal, so it cannot recognize it where it is in the whole area. So at that time, we deployed our lighting module on the ceiling, like lighting fixture, and we attach our sensor to a light in the vehicles at the left side. So when the sensor detects the light from our fixture, it can recognize it and resend to the maps or the other system. The right side is for self-driving robot, the same feature. So I prepared another video. So this is for extended work. Yes, we attached the polarized light source on the top, and we attached the sensor part to this kind of weird robot. Yeah, basic principles, as I said before, there's polarizations. The sensor part is comprised of special geometry, and its face has 4 types of photodiodes. Yeah, this is the yellow guy has a Bluetooth gamepad, so it controls the robot movement by using controlling. Then the final result shows that left side. So green dots means 3D positioning of the robots, and green arrow the heading of the robot. So we collect 2 things, position and also heading. So 6 to F. Now this is our office top view. And this is raw performance. If we apply very simple Kalman filter for our result, then you can see the red dots on the left side. It shows that the line, so very simple but accurate. You can show the movement of the robot. So it has interference. If we do some very strong light to a sensor part, it shows a stable state. And also, if we occurs occlusion problem on the sensor part, it shows that very weird movement, it detects again, it shows that if it detects again, it shows that real-time recovery for their position. Yes, this is how it's done to work. So actually, I'm not a CEO of the SOCAR, so I always the CEO of the Polarized. So Polarized means that polarization plus end. Actually, several years ago, I founded my own company using this techniques. So recently, our first target, first application was virtual reality, so mobile VR positioning solution, and second target is precise indoor positioning solution for mobility market. So recently, we are acquired by SOCAR in April 2019. So SOCAR is #1 mobility platform company. We do in South Korea and Malaysia, and so we do in 2 kind of service. First, in car sharing, and second, ride hailing. So SOCAR and Tata. So and also SOCAR owns 13K vehicles and 5K parking zones. So we add the capabilities of embedded system for the larger scale flood management and indoor positioning for SOCAR. Yeah, this is my presentation. Thank you.
Any questions or comments from audience? So I have a question.
Yeah.
If you apply this to VR application, I'm afraid that detection area, the size of detection area is limited because light source is equipped in headset, and you hand your device. So detection area is very limited. So did you estimate the detection area in the case of virtual reality application?
It actually it's very similar to the FOV area for mobile VR headset, because as you see before, we only using single light source. So and also it covers the maximum length of the distance is limited by the length of the arm. So only cover like this one. So in this work, we support only this area, but if you use more strong light source and then multiple light source, we can cover more bigger area.
Okay. Yeah. Please. Yeah. Okay.
Thanks. On your last experiment, you hide the sensor from the camera, and you don't know where the robot is anymore. But do you apply the Kalman filter during that experiment? And if not, what will happen if there is a Kalman filter?
You mean the evaluation part? No, or this video part?
On the video part, when you hide the sensor.
Yeah. So when we are applying, where we are applying the Kalman filter is after the final result of our algorithm. So we apply Kalman filter to the 3D position of the original algorithm. That shows that red dots. Yeah.
Okay. Thank you.
Other questions or comments? Yep.
Kyora, how do you see the increasing prevalence of using directly the user's hands in virtual environments impacting your work? Could you speculate on how they might intersect or what it could mean?
You mean the occlusion problem, or?
No, I mean, so you have this very neat controller, but we're starting to see a drift towards doing away with controllers and just mapping the user's hand position directly. How do you think that might impact your future work, or what do you see there being any intersection?
You mean the hand movement of the, so it can occur the interferes for 6-UI positioning?
No, I mean instead of using this controller,
Yep.
Or any controller, some people are just mapping the user's hands and using their gesticulation to control the application or game.
Mm-hmm.
So with that being something that is happening now, how do you see that impacting your future work?
I think yes, yeah. So recently I've got some, I saw the hand mapping application only using camera, right? So it doesn't need any kind of controller. It has, it is pretty good approach, but actually, when we do, this is my opinion, when you do something in the virtual reality, when you do some like FPS game like Gun, we need some feedback, right? And then we need some, I think, at that time, we need some feedback from the controller. So at that case, we need some more special apparatus for virtual reality experiences.
All right, thank you.
Are there questions or comments? So I have another question. Yeah, I think this is the opposite implementation of motion capture.
Right,
Yeah,
right,
right,
exactly, right.
So this detects the position using its marker itself, right?
Mhm.
So I think there are many other applications, such as how about implementing it robotic arms. So usually visual servo is is under research, but visual servo needs much computation. So if you implement, if you equip your unit into the, how do you say, joint part. I don't remember.
For the marker, right?
Yeah. So robotic arms can be controlled based on real position of each, how do you say, articles.
Mm-hmm.
right?
Vertical, yeah.
Yeah, yeah.
So,
How about this idea?
yeah, pretty good. So this is Warrior's very first approach using the light polarization for 6-step partitioning. So it has this very low level as an algorithm, and even that part we can apply that area. So I think that's a good idea for enhance to mapping. Yeah.
How small can you make it? This unit?
Actually, we only use photodiode. So when we apply very MEMS process for only this kind of sensor, we can make it very smaller than the other one. But at this time, so this is a very prototype version, but total the sensor part is very similar to the size of the ping pong ball, the half side of ping pong ball. So we can make it smaller than this one. It depends on money and the time.
Okay.
Yeah.
Any other questions or comments? Well, yeah.
So I noticed that at the demos we had the other day, there were some issues with reflective surfaces and competing sensor fields. Do you have similar issues?
Reflection from the polarizer, right?
Sure, or from surfaces in the environment. Yeah.
Yeah, we have this similar issues, but when the light it occurs, its reflection, it loses the polarization, so it does not affect to our work. So that's a bit basic, but at that time, the other polarized light can affect us. So in that time, so we apply the modulation to recognize only our signal. Yeah.
Thank you.
So, so if there are no other questions and comments, we move on to the next presentation. But let's thank our speaker again.